Strings is an audiovisual installation in which we wanted to connect the idea behind the string theory in physics and the actual vibration of the strings. We have a subwoofer which is connected to a screw which then activates the string, and then the sound actually travels all the way to the resonant box, and it is being then collected by 3 types of different microphones.
In my art practice, I'm trying to deconstruct certain ideas that normally we take for granted. In this example, we are analyzing what music really is, how sound is constructed, and what kind of connection it has with physics in a broader sense.
In this work, we present preliminary results of a project in which we investigate the possible soundscapes of the future. The starting point is a project by documentary director Erik Gandini, in which he investigates, among other things, how our working life and society will be in a future dominated by artificial intelligence and robotic automation. In this context, we asked, what will be the soundscape of the future? As a first step in our investigation, we organized a design fiction workshop at the Interactive Sonification Workshop 2019 at KTH in Stockholm. The results from the workshop are presented in the poster and in the related paper. Thank you for watching. We wish you a good vision of the poster and we look forward to an interesting discussion with you.
My name is Emma Frid and I'm going to present the work Haptic Music, exploring whole body vibrations and tactile sound from multisensory music installation. And this is a work that I did together with Hans Lindetorp. Sound Forest is an ongoing project between KTH Royal Institute of Technology, KMH Royal College of Music, and the Swedish Museum of Performing Arts. Sound Forest is a multisensory music installation that presents whole body vibrations through platforms in the floor. Within this project, we held a workshop focusing on perception of whole body vibrations with 5 composers. We asked the composers to stand on haptic platforms, and then they were asked to describe the haptic sensations that they could perceive. After that, we asked the composers to produce 5 multisensory music compositions for the Sound Forest installation. Our findings suggested that awareness of haptic music could be improved through training. We also found that there was a wide range of haptic experiences described for the same haptic stimulus. And this highlights the need for large-scale studies on whole body vibrations, especially in the context of music and music installations.
This poster introduces a tool to program the ESP32 microcontroller with a Faust programming language for real-time audio signal processing applications. Faust is a domain-specific language targeting high-performance audio signal processing applications. Faust can already be used to program other types of microcontrollers in embedded platforms such as the Raspberry Pi, the Bella, the Tinzy, the Elk, or the Owl, but here we demonstrate how such tasks can be achieved on the ESP32. The ESP32 is a series of low-cost, low-power embedded systems with integrated Wi-Fi, Bluetooth, and microcontroller distributed by Espressif Systems. Various ESP32-based boards target real-time audio applications such as the Liligo TTGO T-Audio or the Lyra T. These boards provide an extended external RAM module, which is important to have when running DSP algorithms with a large memory footprint. Faust programs can be turned into ready-to-use C++ objects for the ESP32 just by running a single command line or by using the export function of the Faust Web IDE. Generated objects take care of setting up the audio driver as well as carrying out real-time audio DSP in the background. MIDI and polyphony support can easily be added as well. For more information, please refer to the poster or to the corresponding paper in the proceedings.
This publication concerns an interactive audiovisual art installation based on a simple algorithm on the Cellular Automaton Rule 110. Actually, the installation is composed by a series of snapshots of the evolution of this algorithm, which are projected. We call those snapshots and those images as shadow paintings because they are projected on the wall or on canvases. The projectors, or the shadow boxes as we call them, were designed specifically for the installation and they offer a sculptural element. Actually, this paper discusses the process of creation of the work and the technical and the aesthetic considerations behind this project. The artistic language is minimalistic, and the aim actually is to express in a simple and a very elegant way the computational significance of this elementary cellular automaton. There is not much technological novelty in it, and the focus is more on the creation of a multisensory meditative microenvironment that celebrates the elegance of this algorithm, and it values a longer, slower, less dramatic and more sensual experience.
Hi, I'm Guilherme Yoshimura and just finished my master's degree at the University of São Paulo. This work is part of my thesis about classified speech disorders. In this work, we present a novel classifier that is based on the similarity profile built out DTW alignment MFCCgrams. We had the support of the School of Medicine that provide a database that contains 200 recordings of 2 Portuguese words widely used in SSD diagnosis. The first one is sapo, that means frog, and the second one is chave, that means key. The database was labeled as disturbed and normal by speech therapists, and 60% of the database were labeled as normal and 40% as disturbed. We compared the proposed method with 2 others SSD classifier, a classifier based on Earth mover distance, and another one that uses a relative DTW embedding known as MinDTW. As a result, our method shows better F measure when applied in the word chave and a similar result in the word sapo.
Hello, I'm Nicolas Figueiredo, and I'm one of the authors of this article you see right now. And if you're interested in time frequency representations or automatic music transcription or music information retrieval in general, this might be of interest to you. In this article, we propose 2 experiments that evaluate different features such as entropy, standard deviation of energy or amplitude, mean energy, and others, as estimators of musical information in the time frequency plane. The idea is that with a good estimator, we can detect regions of a spectrogram, for example, that contain notes or harmonics or other musical elements. And on top of this, we propose an adaptive multi-resolution representation that would represent with higher detail these areas that contain relevant information for music transcription, and with less details the areas that do not. Of course, this is only the general idea of the article, and if you have any questions, please feel free to ask, and I'll be happy to answer them. Thank you.
Hello everyone, my name is Untitled Chapter from Karma, and I will be talking about embedding electronics and functional parts in the additive manufacturing process for digital musical instrument design. In this work, we introduce the musical implementations of embedded sensing by integrating sensors and passive components in the 3D printing process using fused deposition modeling technology. We test the proof of concept in 2 instrument prototypes, a variable interface to capture hand and finger gestures, and an augmented alto-flute design. This method allowed us to design compact sensor modules, customizing interfaces, cleaner surface finish, and adhesive-free instrument augmentation. In this ongoing project, we describe the design methodology, implementation, and its possible applications for music. We further discuss its use cases, advantages and challenges, provide future directions for exploring applications of audio electronics printing methods, and corresponding sensor designs. Thank you for listening. For more details, please see our paper. And if you have any questions, feel free to email me.
This poster looks at a recent kinetic sound installation called Menagerie that was presented at the Danish National Museum of Music in Copenhagen in November of 2019. Inspired by the collective behaviors associated with biological swarms, Menagerie is a kinetic sound sculpture that mechanically activates the deconstructed automatic rifle gun trigger as an autonomous sound object to evoke the repetitive nature of gun-related violence. Using statistics taken from the occurrence of firearm-related deaths from each U.S. state, 50 custom-fabricated gun triggers are subject to a variety of self-organizing and behavioral algorithms where they align, synchronize, and evolve, revealing the emergent polyrhythms inherent in American patterns of violence. More specifically, this installation uses a network of coupled oscillators to recreate the acoustic dynamics of swarms. The empty gesture of the unloaded cold clicking trigger is emblematic of the listlessness of political action and redress. In this piece, this sound is used as a medium through which the trigger swarm aggregates sonic mass to expose and sonify the timbral density of gun-related violence. This poster presents an overview of the compositional process involved in the design and fabrication of the automatic rifle triggers, the programming and sonification of the coupled oscillator network, and the aesthetic ramifications of composing for the trigger as a cultural object.
The objective here is to convey the richness of music through a visualization that should be accessible to non-music experts while being self-explanatory. So here is a prototype on Bach's The Art of Fugue. The visualization is performed real-time and will be presented in a concert next year by the Danish String Quartets. For that purpose, we needed to integrate a score following.
Hello everyone, my name is Georgios Fruitsos and I'm a PhD student at the Sonic Arts Research Centre in Queen's University Belfast. This poster presentation is about the research I completed during my Masters. This paper talks about the combination of sonic arts and cultural storytelling regarding the peace walls in Northern Ireland. My main focus was on the peace wall between the Falls and Shankill Road in West Belfast, stretching over 2 kilometers in length and about 14 meters in height. These walls were placed during the Civil War, which began in 1969, referred as the Troubles. They were supposed to be a temporary measure. However, in 2020, these walls still remain, even though the conflict ended in 1998. The two artistic research projects conducted were to use audio to augment perspectives by forms of accessibility and engagement, as well to represent space and identity through sound. These were approached with a combination of socially engaged arts, urban arts, sonification, and the embodiment of sonic arts. The projects were created with the main concepts of spatial audio and sound walks. Project 1, Divided Spaces, is an ambisonics installation piece for an offsite experience, and Project 2, Peace Wall Belfast Sound Walks, is 6 mini compositions for an on-site experience. While both projects have different forms, they are connected by the dual purpose of the material gathered from the Peace Wall, creating new listening experiences to provide another sensory exploration through sound, and having art promote the discussion of conflict transformation and peace resolution in Northern Ireland.